Hello students, welcome to the Section 7.5 notes. Sorry we couldn't finish them today, but I'm going to go over them quickly so that you have them. We have to stay on schedule, so we have to take the quiz next class. I have a short lesson to teach after the quiz next class. That gives you your test review on Friday and then the test on the following Tuesday. Again, I won't be here on Friday, so you'll have a whole nother video. Looks like I have to redo it because the sound never went through on it, but I'll upload that shortly. So the warm-up we started, we have 28 as a result of this. Just be careful, make sure you set your whole side of your small triangle to the whole side of the large triangle, and same on both sides for the left and the right. This one, we got approximately 3.428. Again, feel free to pause the lesson at any time if you need to catch up. Number 3, we got approximately 9.8. So in this case, you would set your proportion up as 7 is to 7 plus x, as 5 is to 12. Again, that is the whole parts of each one of those triangles. Find your cross products and solve, and you'll get x is 9.8. Okay, we have this one. We can say 7.5 is to x, so this part is to the whole thing, as 6 is to 9. As 6 is to 9. Find your cross products and solve, and you will get a result of 11.25. Okay. Remember, side splitter theorem now says that if we do have a line that is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. I'm going to draw a little diagram of what that means. I have the ability to make nice parallel lines here. So I'm going to draw a triangle. Yep, that's good. And I'm going to replicate that. Well, let me do it right here. Okay. I was able to draw it parallel because my software allows me to. And if we have parallel lines, we have A, B, C, and D. Instead of saying what we used to have to say, which is A over A plus B equals C over C plus D, we can now say that that is also the same as A over B equals C over D. And the only reason why, again, is because this part here is proportional, and I'm not going to use tick marks, but I shouldn't use tick marks, that this part A is proportional to this part B, as this part C is proportional to this part D. So each one is in ratio to one another, making them proportional. In class, we also summarized that there's a bunch of options here, assuming that this is one triangle. It's not, it's just parallel lines. So in between each one of these parallel lines cut by these transversals, if we did ignore that and not have a triangle, A is to B as C is to D. Okay. We did this first example in class. Instead of saying x is to x plus 16, as 5 is to 5 plus 10, working with our whole parts, we don't necessarily need that. We can just immediately go into this right here. X is to 16 as 5 is to 10. Find your cross products. We'll get 10x equals 80, and divide both by 10, and we'll get x is 8, which is what we had. The next one, you just set up x plus 1.5 is to x, as 5 is to 2.5. We are going to find our cross products. 5x equals 2.5 times x plus 1.5. I have a calculator near me, so I'm quickly going to solve this. We have to use the distributive property, don't forget. That's 3.75. We are going to take 2.5 away from both sides. And we have 2.5x equals 3.75. Divide both by 2.5, and we have 1.5. And that looks perfect, because look at our proportion here. We have 2.5 is to 5, so that's double. So 1.5 would be to 3, and that's double. Good. The real world example. Making a sale. Sale makers sometimes use a computer to create a pattern for a sale. Some of you live in Jamestown and North Kingstown, so we live on the water, and we tend to see a lot of sailors around our area. After they are cut into panels of the sail, they are sewn. They sew them together to form the sail. The edges of the panels in the sail are at the right are parallel. So what we have is we have some parallel lines here. We have this one parallel to this one, parallel to this one, parallel to this one. I'm using one set of tick marks because they're all parallel to one another. We can set up any of our proportions for any parts of these. So the first one I'm going to set up is 2 feet is to x feet as 1.7 feet is to 1.7 feet. I hope you can see where I got this from. 2 is to x as 1.7 is to 1.7. Because they're both the same measure, you really don't have to do your cross products, but you can. You'll get 1.7x equals 3.4 and divide, and you get, voila, you get x equals 2. It's the only number here that would work. So x equals 2 feet. We're going to do the same thing for y, but we are going to instead do 2 feet is to 3 feet, whoops, as 1.7 feet is to y. And here I'll show you where I got this from. I set 2 is to 3 as 1.7 is to y. I can use any part of that I want to. Find our cross products and solve. We're going to get 2y equals 1.7 times 3 is actually 5.1. Divided by 2. Y equals, that's going to be 2.55 feet. Y is 2.55 feet. X is 2 feet. It makes sense. The larger one side gets, the larger the other side's going to get. It's about 50% increase from 2 to 3, right? It's half of 2 added on. It's going to be half of 1.7 added on, which ends up being the total of 2.55. All right, the next one, we have solve for x and y again. In this case, what you want to do is you want to use 15 and you want to use 26 for both solutions. And the reason being is that it's already given to us. Even if we were to make one mistake, we were given, we hopefully won't make it again. We're going to set 15 over 26 equals x over 30. And the other one we're going to set up is going to be 15 over 26 equals 16.5 over y. Whoops, that didn't look like a triangle at all. 16.5 over y. In both cases, you notice I go 15 to 26. I'm going from left to right in my setup, and so I need to go left to right as well. Same thing with the what's in orange. I went from left to right. That's how I set up my proportions. So, whoops. Okay, find our cross products. Let's see, the math here is 26 times 16.5. Okay, so I get 15y equals 429 for this one. In orange, I'm going to do 30 times 15. That's 450. So 26x equals 450. And divide that by 26. I get x approximately equals 17.3. That's rounded to the nearest tenth. If I round to the nearest hundredth, it's 3.0. It's 0.307, so it'd be 0.31. But I think I'm just going to leave it as to the nearest tenth. And for that one, let's see, 429 divided by 15 is exactly, x is exactly, oh, I apologize, y is exactly 28.6. And the question is, does this make sense? Well, if I have 28.6 and I have 17.3, take a look at that proportion right there. As 15 becomes 16 and a half, it gets larger. So 26 gets larger and becomes 28.6. Yep, that's proportional. And then even larger than 16 and a half is 17.3. So larger than 28.6 has to be 30, and that is proportional as well. So yeah, this definitely makes sense because all the smaller parts, as they increase, so do the larger parts. They also increase realistically and proportionally. Okay, the next one, triangle angle bisector theorem. This says that if a ray bisects an angle of a triangle, so here we go, for instance, here's the bisector, whoops, here's the angle bisectors right there, right? Angle bisector, which is actually this ray right in the middle here. Boom, that ray. Ding, that's your angle bisector. It's a ray. Cuts the angle right in half. Angle K is cut into JKR and SKR. So that angle bisector comes down. Then it divides the opposite sides into two segments that are proportional to the other two sides of the triangle. Okay, cool. So let's look. Let's solve for each proportion here. In this case, I'm given RS. So this part right here, I'm given. And I need to know what it's proportional to. Well, I know that's proportional to JR and KJ. So I hope you see this, that RS, this part, is proportional to, I'm sorry, RS is proportional to something that we don't know, but JR is proportional to KJ. Well, the only thing that would match up here is KS. We want to make sure we go in order though. So RS, let's look at this. RS and SK as JR is to KJ. Let's see, I don't really like the order of these. We have RS and JR is flipped. So we have KJ. Let's see. Order should matter, and I think the textbook messed this up. JR and KJ. It really should be it should be SR, because it really should be going the other way, and then it should be KS. So let's just clean that up. So let's see, JR is to KJ as SR is to KS. Yeah, that's how it should match up. Okay. The next one, we have KJ. KJ is to JP as KS is to what? Well, SQ. That's the only other one that works there. Good. And again, you just kind of need to look at these as two triangles. Here's one, and then here's the other. Here's one, and here's the other. Here's one, and here's the other. You have three sets of triangles that all have different proportions. So we have QL. Let's take a look. QL. We have this part, and PM, that part, as we have SQ. So what does that match? JP. It's the only thing that matches up proportionally with the parts that were picked. Okay, the next one, let's start with TQ and KQ. So TQ, TQ, and KQ as PT. Again, I don't like this order. I really think we should go as TP is to KP. So it's not that it's, I don't know, similarity is a little different than congruence. I still think we should go in order. I think we should say TP is to KP. So let's just edit that one. Okay. If they're moving towards each other or they're moving away from each other, or that order should matter. So we have KL, we have this part is to LW, that part, as blank is to MW. And that's going to have to be KM. This one will be KM. Whoops, my apology. Now we have LQ, KQ, LQ, KQ, LQ, and KQ. And we have KP was given. So what are we missing? Well, we're missing MP in this direction. So MP. All right, we have JK and KS. JK, 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 and we have KS. And we're also given SQ as one option. I'm not sure what's going on here. SQ. So we really should be given PJ. So PJ is to SQ. PJ. So in reality, PJ, this one, is similar to SQ as JK is to KS. And lastly, we have KL. KL, this whole thing, is to KM as MW in the denominator, MW, MW. We would have to have LW, LW. So it's read KL is to LW in that order. Or KL is to KM as LW is to MW in that order. I apologize. Okay. Here's using a more appropriate version of it. It's really cool here. The triangle angle bisector theorem does not mention that the triangles are similar. Just that the segments are proportional. So I don't want you to look at these triangles here and be like, oh, these are perfectly the same. It's just one is an enlargement of the other. It's a dilation. No, let's look at this visually. Does this triangle here look at all like this one, even when it's expanded and enlarged? It's not true. All we know is that they're proportional. So here's how we set up a proportion and solve for x. We are going to say that 5 is to 5 is to 8. So I always go across my angles. I always start with the smaller triangle, or what appears to be the smaller. So 5 is to 8 as 6 is to x. So you go smaller, larger, smaller, larger. And I always start with going across from that angle, that bisector. And that angle bisector, again, the angle bisector divides the opposite side into two segments that are proportional to the other two sides. So it divides these two segments into proportion with the other two sides. And we quickly can solve this. We're going to just do 5x equals 6 times 8 is 48 divided by 5. We are close to 10. It's 9.8. Wait, nope, I'm sorry. 9.6. 9.6. Let me just make sure. 48 divided by 5. Yes, 9.6. Okay, let's do another one. This one we are solving for y. Again, I start with the smaller. 3.6 is in proportion, is in ratio with y as 5 is to 8. Back to the smaller, back to larger. Some students are going to ask this. Hey, Mr. A, can I do 3.6 is to 5? Can I do 3.6 is to 5 as y is to 8? Can I stay within the triangles? Guess what? You can, because watch what happens. What's 5 times y? Isn't it the same thing as y times 5? It's going to work out. But I do like you to compare the parts that are supposed to be the proportional parts, because that's what the theorem says. So again, I like to go opposite angle with the other two proportional sides. But it's not wrong to set them up. As long as you don't do 3.6 is to 8. You can't compare those. Those don't compare. Either 3.6 compares to y like I am choosing to, or 3.6 compares to 5. It cannot compare to 8. So we are going to leave that. You know what? I'll leave this for our notes that I'm uploading, just so people see where I'm getting it from. Okay, so I find my cross products of this. So it looks like we have 5y equals 24 and 4.8. So calculator 28.8. 28.8. We're going to divide that by 5. So y is equal to, y is equal to 5.76. 5.76. So y is 5.76. X up here is 9.6. Okay, that's the end of the notes. I'm going to keep going and do the homework problems. Feel free to follow along. I'm just going to quickly explain them. That was the end of the teaching. So if you want to keep watching, you can. Or you can pause it, try to do the work on your own, and then check over the answers using the solution key on Google Classroom. Okay, so for doing this, 8 over 10 equals 6 over x. 8x equals 60. divided by 8. 60 divided by 8. Whoops, 60 divided by 8. We have 7.5. X equals 7.5. Next one, x plus 4 over 2x, 9 over 12. Find cross products and solve. 18x equals 12x plus 4. Don't forget to distribute to both terms. We get 6x, take away 12 from x from both sides. 6 times 8 is 48, so x equals 8. And last one, x over 13 minus x equals 2 over 3. 3x equals, distribute to both terms. Add 2 to both sides. To do this right, 13 minus x times 2. Yep, so divided by 5. X equals 5.2. I believe that's right. 5.2 is to 7. Yep. Alrighty, fill in the rest. A is to B, as this would have to be D is to E. A is to B as D is to E. We have E and F, so we need B and C in that order. Next one, F and E, so going in this direction, F, then E, then C, then B. B is the only option in that one, in that order. Then we have A is to B plus C, as what is to E plus F? Well, D is my only option. Okay, solve for x, a couple more here. 4 over 6 equals 5 over x. Just a different way to look at it. 4x equals 30, so x equals 7.5. 4 over x equals 6 over 5. 6x equals 20. So we divide both sides by 6. 20 divided by 6. We have 3 1/3. We could write it as 3 1/3 or 3.33 repeated. Don't forget to put your vermiculum over your 3's to show that it goes on forever. This one, okay, well, in this one, we might as well set it up in an easier way. Instead of doing 24, take away what we know, which is x, which is unknown. We know an unknown. That actually causes us a little bit more of a challenge. There's just a lot more distributive property. Just set it up like you would have before. X is to 24 as 8 is to 20. So I'm doing part is to whole as part is to whole. And it leaves me with one variable. And a very quick calculation. And we have 20x equals 192. So divide both sides by x. X equals 20, and x equals 9.6. Okay, that was much quicker. These proportionally, they're proportional. They are not similar. So we have to say x is to 5 as, oh, it looks like I just went against my own word. I said normally you go from small to larger. So let me fix that. 5 is to x. That one looks a little bit smaller. 5 is to x as 10 is to 12. So 10x equals 60, x equals 6. Yep, just a little bit larger. 3 is to x as 5 is to 8. 5x equals 24. Divide both sides by 5. We get 4.9. Let's see. 4.8, I mean. Yeah, 4.8. Okay. 8 is to 14 as 20 is to x. Again, these should all be making sense after we divide them and we comparing the sides. If you get some abstract number, probably did something wrong. X equals 35. Yeah, that makes sense, right? 8 and 20, and now 14 and 35. It's a little bit larger, almost double. This one, we're just going to mark this as 6, take away what I know, which is a variable. So it's going to be x is to, actually, I'm going to do smallest to largest. So 6 minus x is to x as 4 is to 6. So I went here, and then here, and then 4, and then 6. So I get, whoops, 4x equals, it's going to be 4x equals 36 minus 6x after I distribute to both terms. Got a mess here because we're running out of room. It's going to fall off the page. So we're going to add 6 to both sides. I'm going to get 10x equals 36. So x equals 3.6 after I divide out the 10. Makes sense? 3.6, and then 6 minus 3.6 is 2.4. Together they add up to 6. All right, again, you know what? Changing the color here so you can see the difference in that work from the last work. So 10 minus x over x equals 6 over 8. So 6x equals, don't forget to distribute. So I get 8, add 8 to both sides, 8x to both sides, I get 14x equals 80. Divide both by 14. X approximately equals 5.7. I'm rounding to the nearest tenth. The last one, 6 is to 8 as 9 is to x. 6x equals 72. 9 times 8 is 72. Divided by 6. We have x is 12. Okay. I'm going to let you do this worksheet on your own. It's all of them are similar. You know what one I will do? Well, this is 1 is to 2 as 2 is to 4. That one's easy. You can solve that. Yeah, I'm going to do this one right here, the fractions. Students tend to freak out with fractions. I don't know why. It's all good. It's easy. You got this. We're going to solve for x. So we have 5/3 is to 4/3 as x is to 20 over 9. Okay, don't freak out. You have a fraction over fraction. Instead of calling it x, don't call it x. Call it x over 1 because anything divided by 1 is itself. What you now have is a nice, clean way of computing these fractions. Rewrite this as 5 over 3, not divided by, but times 3 over 4. Multiplying by the reciprocal is equivalent to dividing by the reciprocal, right? So 4/3 and 3/4 are reciprocals of one another. So 5/3 divided by 4/3 is equivalent to 5/3 times 3/4. Flip it. And then over here, instead of calling it x, I called it x over 1 because it makes it easier for me to calculate. Multiply by 9 over 20. That gives me 15 over 12, or I can just do this. Hopefully you see that. You can simplify if you want. That makes it easier. 5 over 4. You don't have to. Again, I could call this 15 over 12. Just simpler to call it 5 over 4. It'll all work out in the end. 9x over 20. Find my cross product. So 36x equals 100. 100 divided by 36. X equals, x is approximately 2.77 repeated. All right, so save yourself some room to do that one. Don't worry about the fractions, you got this. Okay, that one was tough. Do not worry about y because I have not showed you how to solve for y yet. So just cross that one out. Just solve for x in number 11. You know what else is going to be difficult? Number 16, because it involves, no, 17 is similar to 16 because you're going to set up your proportion and solve. But it's going to involve maybe some quadratics here. So I'm going to do x minus 1 is to x plus 2 as x is to x plus 4. Find my cross products. And that yields you with x times x plus 2 and x minus 1 times x plus 4. Do not forget the distributive property. You have to do this multiple times. X squared plus 2x equals x squared plus 4x minus 1x minus 4. Okay. Simplify by combining my like terms. Take away what I don't want from both sides. Well, I don't want x squared. And guess what? That's really nice. A lot of stuff went away. I'm running out of room. Go right up here. We have, 2x equals 3x minus 4. Take away 3x from both sides. We have negative x equals negative 4, so x equals 4. All right, a lot of work for that one, but we got x equals 4. So it's going to be 4 is to 3. Yep, so that all works out. You're going to do the same thing for number 17, so similar to that. Okay, I think that's where I'm going to end the video. I'm looking, I don't see any that stand out. Maybe this one right here. You know what? X has to equal 6 and Y has to equal 6. I mean, that's self-explanatory, right? You have congruent triangles. These are isosceles. The base angles are the same. Everything's perfect. X and Y are split in half. We're going to use 2 tick marks. Yeah, that one's pretty simple. Hopefully you see that. Okay, have fun solving the rest, and I am going to end this video where it is. And that, again, was a recap and review of the Section 7.5 notes. Have a nice night.